Hello, welcome to video number 70. Today we're going to talk about advanced volume problems. One situation we've already talked about, so this will be kind of a review for you, and another situation is new. All right, let's take a look first at the old situation. We've talked about this already, but this problem has several steps, so it's okay to go through it again. We want to talk about making cylinders out of rectangles. So we start with a rectangle and we connect two opposite sides. In this case, we're going to connect the short side. So this side that's 14, we're going to tape together with this side and make the cylinder. This is kind of what happens when you put a label around a soup can or a can of green beans. If you've ever pulled off the label and unfold it, it's a rectangle. Okay, so we want to find the height of the cylinder and the radius of the cylinder. The reason why is if we look at the volume formula down here for a cylinder, in order to compute its volume, we need the radius and the height. So somehow we have to find those two things. Well, when we connect the short edges, the height is going to be 14. The height of the rectangle is the same as the height of the cylinder. So that one is easy. H equals 14 centimeters. We have to do a little work to find the radius. When the rectangle is built or put together as a cylinder, this top edge becomes the circumference here. So the circumference of the cylinder is 37 centimeters. And we have to find the radius from that. So we know from circles that circumference is 2 pi times the radius. So if we put 37 in, that equals 2 pi times the radius. And so the radius is what you get when you divide 37 by 2 pi. And you get a decimal. I get 5.9, and that would be in centimeters. It's a length. Okay, so we have the two things we need. We have the height of the cylinder, and we have the radius of the cylinder. The volume is the easy part. So we just do pi times the radius squared, 5.9 squared, times the height. And we get another beautiful decimal. If you do this, I believe we get 1,531 cubic centimeters is the volume. So the units are cubic units. All right, that was the old, and with the new. So we've talked about volumes of pyramids before, but this one involves a little bit more. So first I want to go over some terminology we need. First, the old terms we already know. In the volume formula, there's a capital B. Capital B is the area of the base. So whether it's rectangular, a square, a triangle, a pentagon, whatever, a capital B is the area of the bottom here. Okay, the other term we're familiar with is height, H. This is the height of the pyramid. And this is the height going straight up and down from it's called the apex of the pyramid, straight down to the ground. So that is the height. Now, there are two new terms we want to introduce. The first is lowercase b. Little b is the length of the side, especially if it's a square pyramid. So in this problem, we're going to be talking about a square pyramid. So b equals the length, if I could spell length, is the length of the base. So capital B, which is the area, would be little b squared. B is the length here, and just b times b would be the area of the base. So that's the relationship between capital B, the area of the base, and little b, the length of the side. All right, I didn't invent this, so it's a little confusing, but there's a difference between lowercase and uppercase. We want to talk about S. S is called the slant height, because it's not straight up and down. It's along the side of the pyramid. So if you go to the top and measure the distance along the side, that's called the slant height. Now, slant height's easier to measure. That's no problem. We just put up a ruler by the pyramid and measure the slant height. The actual height's a little bit harder. Okay. So that's the vocabulary. Here's the problem. So here's an example problem, and to be honest, this was kind of taken from the quiz. It looks almost exactly like this on the quiz. It says, in the square pyramid below, it's a square pyramid because the base is a square. The slant height, S, equals 26. So along the side of the pyramid is 26. And it says the base length equals 20. So that's B. All right, use the Pythagorean theorem to calculate the height. Well, if the base length is 20, this length here from the center to the side is 10. And what we have is a right triangle. So I'll draw it separately so we can kind of see it. So in the middle of the pyramid is this right triangle. This side, vertical side here is the H. That's what we really want to know so we can compute its volume. This bottom leg is 10, and this hypotenuse, which is the slant height, is 26. So we can use these two numbers and the Pythagorean theorem to calculate the height. So the height squared, that's one of the legs, plus 10 squared equals 26 squared. Okay, if we solve for h squared, we get h squared is 576. And h would be the square root of that, which is 24. So the height is 24. Okay, now we have the height. We can calculate the volume. So the volume is 1/3 the area of the base. Base is 20 by 20, so it's a square, so it's 20 squared, times the height, which we worked hard to find. And if you put all this together, you get 3,200 cubic feet. Okay, so it's not too hard, just a lot of little parts. All right, here we go. One more example. All right, so this is a slightly different problem, same setup, same questions, but this time the slant height equals 41. So that distance right there is 41, and the base is 18. Remember, that's the whole length of the base. So this little part right here is half of that because it goes from the center of the square to the side. So that's 9. Okay, so the height squared plus 9 squared equals 41 squared. Okay, so again, we solve, do the Pythagorean theorem. We get h squared is 1600. So h is the square root of 1600, which is 40. Okay, we're kind of done with this, but I'll show you the triangle just in case it helps. So the slant height was 41. This segment down here at the bottom of the triangle was 9, and that was the height. And that's what we use the Pythagorean theorem on. Okay, calculate the volume. Volume is 1/3 the area of the base. The base is 18 by 18. So this is 18 squared times the height, which is 40. We do the multiplication, and I got 4,320 cubic feet. Wow, so this height was feet. That's it. Now, that was pretty quick, but that's all there is to the pyramids. This is exactly kind of what was from the quiz. So not only do we have to understand the volume formula, if I give you the slant height and the length of the base, we can find the actual height of the pyramid. All right, I'm going to give you 2 problems to work on. Here you go. First one, this should be getting very familiar. We're going to connect the short sides of the triangle. So this 9 centimeter side and this 9 centimeter side, we're going to put together to make a cylinder. So find the height and the radius of the cylinder and calculate its volume. You've done a few of these now. Here is the new problem. The slant height is 20, so S is 20 on this. And the base here is 24. So that little length right there from the center of the square to the side is 12. Okay, go ahead and figure out the height and the volume of the pyramid. Good luck.